Hi everyone, this is John. I'm going to be doing a quick review of a Zeus Miner rig today. I'm a Zeus Miner customer and I've been in Shenzhen for the past week, checking up on progress at the factory and seeing the first batches of rigs go out earlier this week, which I think was Monday night. I received my first batch of machines yesterday, and so I took one of them back to the hotel to play around with, so I stayed up late checking clock speeds, hash rate, power consumption, heat, and so forth. Terry Lee asked if I'd be willing to do a review, which I said I was happy to because I think the community needs as much information as possible to make informed decisions. The only stipulation that I made was that if I'm going to do a review, I only want to do a completely honest review, so there's no compensation for this, there's no quid pro quo. So this is the standard large rig that they have that forms part of the Lightning. In terms of size and weight, it's 209 by 183 by 402 millimeters, and it weighs approximately 10 kilograms. There's 4 heat sinks inside, which the Zeus guys refer to as blades, and attached to those blades you're either going to have a 24 chip board or a 32 chip board. And the 24 chip board performs at 5.5 megahash or thereabouts, and the 32 does about 7.5 megahash. The original Lightning design was going to be 72 megahash with 4 blades, so 4 heat sinks with 2 boards on each heatsink. And from the updates that Terry has provided along with what we've learned, essentially the heat and the power consumption of those boards was just higher than anticipated, which in the ASIC development world isn't all that uncommon. So now they're moving toward a slightly different configuration with a shorter heatsink, essentially a half heatsink with just one board per heatsink, and they want to go with a shorter but wider rig, so you'd have 1, 2, 3, and 4. And in terms of this case, because I'm a bulk order customer, I have a slightly different setup because I'm trying to optimize for my configuration. So I've actually got 1, 2, 3 of the half-length boards and one full-length board with 2 boards on it. So this ends up being about 27.5 megahash. And I can show you what that looks like when I open up the case here in a second. The airflow is pretty decent. We've got 2 fans here at the back. They're in a pull configuration, and they're both doing about 92 CFM. There's no fans at the front. It's just air inlets, and you can see these are the fins from the heat sinks. So we've got 1, 2, 3, and 4 heat sinks there. We've got 12 screws that hold on the case, probably a little overkill, but that's fine. And we've got 8-pin power connectors at the back. In this configuration we won't use those because I've got 5 boards in here. I'm actually using 5 of the power connectors. And then we have the USB-B connector, which connects up to a Silicon Labs USB to UART connector, and they've got drivers for that on their website for 64 and 32-bit Windows, for Linux, for Android, and for Mac OS X. So this is the interior of the case. I've got the one full-length heatsink here with 2 boards and 3 of the half-length with 1 board each. Down here we've got our USB to UART, and so that actually plugs in directly into the control board here via USB. And then each of these boards is daisy chained together. So you've got 0, 1, 2, 3, and 4, and they're all connected through this control board. The cable management is not terribly good. I don't think it'll affect heat all that much because it doesn't seem to be blocking airflow significantly. One one of the things that I had them add was 2 cables to the 12 volts so that I could actually pass this out the front and hook up another set of fans, 2 more at the front, so I could have both push-pull. I wish they would have included that with this design. I think they can actually do it, because what they can do is these half-length ones, they can move to the middle of the case and actually put 2 fans in the inside. But in terms of, you know, my solution, it was just something that I wanted to do. It may not even be necessary, but where I'm going to have these rigs operating, the ambient temperature is a little bit higher than it is here, and I just prefer to have higher airflow, keep them a little bit cooler. Okay, so I've got all the power leads connected up to the rig. The power supply is an HP Blade power supply that does 1300 watts, and it's actually one of the test power supplies that the Zeus Miner guys let me borrow for the night as I was testing things at my hotel. I'll be running CG Miner off of my little Atom netbook, and I've got that connected up via HDMI to this LED screen so we can watch the CG Miner output and also look at Light Guardian to compare. Alright, so we're turned on now. You should be seeing the device come up in the computer. Bring this over here. So it comes up as the Silicon Labs CP210X, and it sees that USB to UART bridge. And what I've got set up here is I put together just a brand new Light Guardian account. I called it Crypto Advocate, and as you can see here, there's no balance, no hash rate. I have 0 active workers. I haven't done anything on this account. If I look at my workers, I've got 1 worker, which I've named Crypto Advocate Review. The difficulty, I set the minimum at 512, as well as the starting difficulty, and the max difficulty at 1500. There's no work that has ever been done on this. So now I'll go over to, this is my CG Miner script here. This is running CG Miner 3.1.1, and if I open up this batch file here, you can see that we're using CG Miner, going to Light Guardian. Here's my worker name, and this is on COM3, which that's the COM port that's assigned to the miner, and I've got the clock rate set at 328 megahertz, which is the stock clock. So I'll go ahead and start this up. I'll actually, I've got a VPN there that I want to kill, so I don't want it to be interfering with our network connectivity. Okay, so I've let this run for just over 20 minutes, and it's starting to settle in. The work utility shown in CG Miner is somewhere maybe around 26.5 mega hash, which if you multiply it by their 1.09 factor, you get about 28.8 mega hash. I don't know if that's entirely accurate. It seems to be that, I mean, this rig is supposed to do about 27.5 megahash, and let's refresh this again. It's just gone down a bit. I've been getting somewhere around 27.8, that was 27.5. I think it'll continue to kind of go back up a little bit after that last 25 megahash reading. But it seems to be right in about that range of 27.5 that it's designed for. Let's go ahead and take a look at power usage. I've got my flute clamp meter here, so that's a DC, we're all zeroed out. That's 65.3. Very little fluctuation. It's really sticking right around 65.3, 65.2. If I stick it on one of the 8-pin, getting 12.6, 12.5. I'm going to go ahead and shut the rig off so that it's not such a noise issue. And here we see it's failing to connect. Now it's disabled. And there we go. One thing that makes management of this a little bit tricky is that there aren't any temperature sensors built into the board, at least nothing that's reporting. I've got like an IR gun to read temperature, but of course if you take the top of the case off, now all of your airflow is disrupted, and so the heat of the chips rises significantly. The only way that I've really kind of been able to do it is if I actually have it aimed, through this fan port in there, where it's actually starting to hit on the heat sinks, which, with the spinning fan blades there, is not a particularly good solution. I think what I might end up doing is actually sticking some temperature probes directly onto the PCB and coming out through the case itself. So that's about it. It's worked fairly well. There was a little bit of a hiccup when we first got started up, where I had my VPN still on, because you really can't get to Google products in China without a VPN. But by shutting off that VPN, then the connection switched over, and so it started to hiccup. So after I did a power cycle on the rig, it came up just fine, and it seemed to be pretty steady right at about 27.5 megahash, which what it's aimed for. Last night when I was doing testing, I saw it going as high as about 29, even 30 megahash. Sometimes it would dip down to maybe about 25 or 26 megahash. So you're starting to get some variation, but over time that starts to average out. So I'm pretty happy with what we've seen so far. I think there's some improvements that can be made and will be made, but I'm pretty happy.